equation, 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 equation,
The following video asks us to graph the line y equals 1/3 x minus 3. To do this, we're going to use the slope-intercept form of a line, which is y equals mx plus b, where m is the slope and b is the y-intercept. So, in this case, the slope is 1/3 and the y-intercept is -3. So the first thing you always do on these problems is to graph the y-intercept. So we're going to go over to that line that is on the y-axis, and the y-axis is always the up and down arrow, right? You see you've got two arrows on there, one going horizontal and one going up and down. And the up and down is the y-axis. And so we're going to go down -3 from the center, and that's going to be our y-intercept. The slope, 1/3, is what we deal with next. And the slope is the rise over the run. The rise in this case is 1. The run is 3. So we're going to go up 1 in the same time that we go over 3. So you go back to our y-intercept, and we're going to go up 1 and then to the right 3 and make a point. And then we're going to do that again, up 1 to the right 3. And actually, you can go the other direction and just do the opposite. Down 1 to the left 3. And down 1 to the left 3 if you wanted to keep going. And we draw in our line, and that gives us the graph of y equals 1/3 x minus 3. That's what that line represents, is that equation. So we're going to do another one of these, and we're going to use y equals mx plus b again. This time, the slope is -4. And whenever we have an integer, we always do -4 over 1, which you'll see in a second. And then our y-intercept is 5. So we're going to, when we do slope, it's always rise over run. And so we need to find a run. Well, anytime you got an integer, you just put it over 1. Okay, so we're first going to graph the y-intercept, which is 5. So we go to the y-axis again, and we make a mark where the y value is 5 on the y-axis. Then our slope's -4, so our rise is -4. So we're going to go down 4, because negative means down. And then you got to go to the right 1. Then we're going to go down 4 again into the right 1. You've got to go to the right 1 or you're going to mess up. So we can draw a line between those 3 points, and that represents the graph of the line y equals -4x plus 5.
Inequality, 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 inequality. Inequality, inequality.
We've been solving equations with one variable for a while now. We know that we want to isolate the variable and place it all alone by itself on one side of the equal sign. Now let's look at some similar problems. Let's see how we can solve one variable inequalities. First, let's be sure we remember our inequalities. We have greater than, less than, greater than or equal to, and less than or equal to. Let's start with a simple inequality. This statement says that the variable n is less than 5. Think of some values that n could be. It could be 4, 0, -12, 4.9, or many other values. We can represent all of these values on a number line. We will draw a number line and shade in all the possible values of n. Since n is less than 5, let's begin by drawing a number line and locating 5 on that line. Since this inequality says that n is less than 5, that means n cannot be 5. It can be really, really close to 5, but it can't be exactly 5. So we draw an open circle at 5. This says that we're not shading in the 5 because n cannot be 5. Now since n is less than 5, we shade in all the numbers that are less than 5. If you're not sure where to shade, pick a value on the number line and test it. For example, let's look at 3. Since 3 is less than 5, it should be shaded in. If we had picked 7, well, we know that 7 is not less than 5, so it should not be shaded. So we shade this side of the number line from 5 all the way to the end of the number line. We also shade in the arrow as well, because n could have any of the other values off this end of the number line. N could be -5, -20, or -1 million. Now let's see how we would graph other number lines. How would we graph 12 is less than y? We would draw a number line and locate 12. We draw an unshaded circle around 12, and we shade in this side of the number line. 12 is less than 13, 12 is less than 15, 12 is less than 100. All the numbers over here on this side of 12. Now, how would we graph x is greater than or equal to 3? Now we have something just a little bit different. We draw the number line like before, and we find 3. Now this time, x could be equal to 3. That's what the extra line beneath the inequality is telling us. So this time we do want to shade in the 3. So we still draw a big circle at 3, but this time we shade it in. We draw a closed circle over the 3. Then we shade in all the values that are greater than 3 as well. And that's all there is to it. Now that we know how to graph inequalities, let's make these questions more interesting. Let's see how we would graph all the values for m that make this statement true. m plus 3 is greater than 10. Well, we begin by solving this the same way we solve an equation. We collect all the constants, all the numbers, together. In this case, we need to remove this 3. And we do that by subtracting a 3 from each side of the inequality. Now this tells us that m is greater than 7. And we remember how to graph this. Draw a number line, an open circle at 7, and shade the number line. How would we solve and graph 4 is greater than or equal to m minus 4? We need to add 4 to both sides, and that tells us that 8 is greater than or equal to m, and we can show these values on a number line. Remember that we can add or subtract values on both sides of an inequality, just like we can with an equation. Let's try one more. Try solving and graphing -3 is less than 4 plus b. We would subtract 4 from both sides of the inequality, and we will see that -7 is less than b, and the graph of our solution would look just like this. Now it's your turn.
Alright, now let's take a look at a larger problem. Now I know this one looks a lot more complicated, but it's not. There's a few extra steps, but they're similar enough to the steps we took in the previous two. We want to get x on one side of the sign, and we want to get our number values on the other side of the sign. And the steps to do that are the same. Alright, so let's start with our x. We have 4x here, and we have a 3x here. So let's take this 3x and move it over here. To do that, of course, we need to add the opposite of positive 3x, which of course is negative 3x. Whatever we do to one side of our sign, we have to do to the other. So we add a negative 3x over here as well. Alright, so a positive 3x and a negative 3x, of course, give us 0x, so they cancel each other out. We're left with nothing down here. But over here, we have a positive 4x plus a negative 3x. So the positive number here is the larger number, so our answer is going to be positive, and the difference between 4 and 3, of course, is 1. So we're just left with 1x or just x. Alright, so let's move over to the right here and let's just bring down our problem. So we have plus 6, bring down our sign, less than or equal to, there's nothing here, and then we bring down our negative 5. Now after taking those first few steps, you can see that our new problem looks very similar to the first two problems we had. And to solve for x, we just continue the process. So I want to have x all by itself on one side of the sign, and I want to have my number values on the other side. So let's take this 6 and move it over here by this negative 5. So I have a positive 6. I add the opposite, which is a negative 6, to get it to go over here. And whatever I do to one side, of course, I have to do to the other. So I add a negative 6 over to this side as well. Alright, so if we go back over here to the left, I bring down my x. I add positive 6 plus a negative 6, which gives me 0, of course, and cancels out. So I have nothing. I bring down my sign. Sorry for that bad arrow there. Which is a less than or equal to sign. And then I'm going to add a negative 5 plus a negative 6. Now in this case, just as in the previous cases, my larger number is negative, so my answer is going to be negative. But this is going to be a little different. Because my values are the same, it's going to be like I'm just adding 5 plus 6. So 5 plus Alright, 6. To plot x is less than or equal to negative 11 on a number line, I create a number line that looks similar to this. I find negative 11, which is right here, and because x has a value that is less than or equal to negative 11, this time, instead of having an open circle, I'm going to fill the circle in. It's going to be a closed circle because the value of x includes negative 11. But it also includes anything that is less than negative 11. So I create a bar to highlight all values that are less than negative 11.